Today there's a large variety of different hands and feet and functional levels of patients. Back when I started 30 years ago, you really were limited to maybe two different types of feet, maybe 2 or 3 different types of hands or hooks, so forth. Today the options are just ongoing, just like a vehicle or a car basically. You have tons of different options. It's come a long way. We still use some of the old type limbs on certain cases. Today we look at patients from a functional level standpoint and basically where they're at that time of amputation, where we think they're going to be in the future, and we try to give them tons of information about what's available and what we see if their functional level is at that time, and where we kind of look in a crystal ball and see where they may be in 6 months or a year. And if it changes, then we'll look at changing that too. We have a lot of different stock of materials of feeding, things that we can try for a patient when they come in. We stock at least 5 different feet for a patient to try while we're fitting them. And they help us make that decision about where they're going to be and what type of device they need. We got electronic hands, we have cable operated hands, we have cosmetic hands. With the feet, we have dynamic feet, meaning that are made for elastic for walking in a yard, such as on uneven terrain. We have feet that are going to give you more speed. They're lightweight, they're going to give you better running potential, such as marathons or sprinting or just jogging. We try to give a limb for a patient that will give them their overall needs, so that they have one prosthesis that will give them the ability to walk, run, hike. However, there are specialized cases that a patient will have a certain prosthesis for fishing, a certain prosthesis for wearing day to day, one for running, one for everyday use. So we see that, and then there's many adapters that you can change, such as here, where maybe they take this adapter loose and they add a different foot for running, and they have one foot for everyday use. They may use one for swimming. So there's, again, one of the popular things today, this time of year, especially in the heat of Atlanta, is swimming. So quite often patients will have they'll take their old prostheses and turn it into a swimming leg, and that's pretty consistent. We try to be economical, so that if we have a socket that the patient, which is a socket, this part here, that fits the patient, we try to find them something from their old parts that we can make for them to use in the water or for individual outdoor activities. As far as knees, they're again going back to the functional level of the patient. Some patient walks step over step, meaning they can walk down stairs, climb hills. Other patients are really just getting from the kitchen to the living room. So there are different needs for patients depending on what their functional abilities are or in how much stability they need. Some patients need more stability than others, meaning that either their limb is shorter or they're just older in age and not as strong. So we have microprocessor knees, in which the knee reads the ground reactions from the floor, and it'll read that 10 to 100 times a second. It'll tell the knee to be stable or the knee to be more flexible, depending on where the foot's at, if it's on the heel or on the toe or in space. This gives the patient a lot more confidence, the ability not to be looking at their feet when they're walking, but to be able to look up in the trees. One of the patients told me many years ago when they first fit a microprocessor knee, probably her biggest benefit was that she was able to carry her baby and wouldn't have to worry about where she was stepping. She could look up in the air or look around like everybody else does and not have to worry about her knee buckling on her. So microprocessors have come a long way. They're not for everyone, but for the patients that can utilize them, they're outstanding. On the other knees that are available, we still have locking knees for people who need a ton of stability. We have various polycentric knees that give polycentric, meaning they have 4 access points that give the knee more stability, and it's a good everyday leg and a good adjunct to a microprocessor knee, kind of the stepping stone to get there. In cases where you have an amputation through a joint, such as through the ankle, These are both pediatric patients, one smaller and one larger. This first one here is for a 7-year-old child. This one's for a 13-year-old. Very similar type amputations. These limbs are held on by the bony structure of the limb. So at the ankle is larger than the mid shaft of the tibia or the shin section. So as they go into this socket, it expands out in this area and locks on, very similar to the Chinese finger trap that many people played with as children, where you stick your finger and you can't pull it out. It's the same way this suspension works. In this particular case, this patient is a little more bony, so they have a flexible rubber material that slides on their limb that stretches out as they go in, and then they push into this socket, and it allows to lock in place through the elastic piece in the bottom. So they get suspension here. This again will be covered, and the foot will be added to this to make the limb both functional and cosmetic. There's no need for any straps or any type design. Also, if you look at the top of this, there's also knee control here. In many cases, children that have this type of amputation are also fibular deficient, meaning that their fibula was not there when they were born and their knee's unstable. So the design at the top of the socket is to control their knee. 90% of these kids run and do pretty much anything they want to do. Very high activity amputations or patients with amputations. This is an above-knee test fitting that we do on all patients. All of our patients are fit with test sockets. It's pretty much the norm these days, but there's some practices that do not provide test fittings. What this enables us to do is not only to ensure that the fit's correct, but also to hear what the patient has to say about things bothering or if it's hurting here and there, as well as we can verify that because it's material that we can see through. We can sense pressure by the skin tension on the limb, or depending on how it is fit. If you see in this particular case where I have areas marked where I've decided to either add material or remove material. Now the test fitting is provided after the patient's either casted, which is plaster wraps made of the limb, or scanned, which is there's a scanner that can be scanned of the patient to get the mold that way. And then we can do it by computer. They're both very good systems of working, but I think the test fitting, again, gives us a chance to evaluate the fit and both to listen to the patient as well as what we see physically. In many cases, there may be patients who do not have good feeling, don't have a good sense of feeling due to diabetes or neuropathy or so forth, as well as to a child that can't communicate besides crying or whatever. But we can verify that the fit is good and before we move on. In many cases, we may fit these a couple of times before we get exactly what we want to go to a finished product. Again, this is another test fitting of an above elbow amputation, very short residual limb. And this particular one will also be a locking limb in which they wear a custom liner that's made out of silicone that rolls on their limb and goes around their chest. This gets suspension as well as control. Inside this liner there will be electrodes placed such as this that will take the feedback from the muscles within the residual limb and provide signal to the elbow and hand that allow the hand to open and close and the elbow to flex and extend. This is done through various monitors that are in place, electronic software that we use to evaluate the fit of the limb. Again, this is all prototype that is made up front before the prosthetic is finished. This will be used with therapy and so forth during this period of time before we come to a finished product that the patient's happy as well as the therapist is pleased with the function. Again, with the test fitting, we'll also, from the electrode settings, we will get signal to the hand, and the hand works very similar to how this proportional control switch works on this hand here. By soft muscle contraction, get soft motion of the hand. Fast motion of the muscle, get quick response. And these are all used through the test fittings of the limb and working with a therapist to obtain adequate function for the patient. Some unique things that we do, I think, compared to other facilities are the use of flexible materials in combination with lightweight, strong graphite type materials. This particular socket is for an active amputee who has very prominent fibular heads or bony prominence of their limb. In this particular case, we're using a flexible inner socket with a carbon graphite frame, so it's lightweight, strong, very similar to what they use in aircraft these days. That's lightweight and strong. And then we're cutting out areas in which the muscle expands and retracts. This gives you a very comfortable fit that is also extremely light and durable. With many of our patients today, we do a lot of different custom designs. As they get more active, they seem to get away from the cosmetic stuff and really want to focus on something more graphic that gets them noticed. You know, I have patients tell me, I know I'm missing a limb, they know I'm missing a limb, so why try to cover it? Let's do something that's going to have fun. And so this particular case, this is a military guy that wants something patriotic, and he comes back with this graphic finish. We have many patients that will come in with their own materials that have a certain design that they like, and we give them graphics. We do that typically by doing an inner socket out of white that lets the color stand out, and then we'll use a carbon fiber, which will keep it lightweight too. And again, it's just another product that we offer, and this is at no extra charge to the patient. We give them this just to make them happy with the graphics that they have and kind of give them a personalized prosthesis.